Hello, my name is Costanza, and this time we are going to study together section 4, which is about wave phenomena. In it we will see the Huygens principle, then based on this principle we will explain the reflection, refraction and diffraction of waves. And finally we will address in the last lesson, the 20th, the one that is common to all sections, where we apply what we have learned throughout the whole section. As we have said, we start with the Huygens principle. In this one, we are going to review the previous concepts that we had seen so far, and we will state the Huygens principle, properly speaking, seeing what consequences it has. Well, as always, Jota and Amanda show us a situation that will allow us to introduce the study. By throwing the ball into the pond, a disturbance has occurred and has caused us to see an image in the water as we have it on the screen. In the previous lessons we had already seen what a disturbance was. Let's move on to this. Jota wonders, well, the perturbation propagates, but what happens to the matter? Well, as we already know, the perturbation, that is, the energy is propagating. However, we see that the pellets remain in place. This tells us that matter does not propagate when the waves propagate. In this perturbation, in which we see what happened to Jota and Amanda when they threw the ball into the water, what happens? We can see or study that the different points are equidistant from the origin of the perturbation. All of these equidistant points, as we can see, are located occupying a crest of this perturbation. It makes no difference whether it is a ridge, a valley, or any point in between. For simplicity, we have taken this one. Well, these concentric circles constitute the wavefront. Wavefronts don't always have to be concentric circles, okay? The wavefront is the geometrical location of the points of the medium that are affected by a disturbance at a given instant. They can be concentric circles, they can be planes, or any other shape of a wavefront. But why is it important that we know the wavefront? Because knowing the wavefront, knowing how the wavefront propagates, we can have information, and we have information of the wave propagation. That is why we emphasize this. That if we in this wavefront, in the different points of this wavefront, draw a perpendicular at each point, what do we have? Well, we have the propagation of the wave itself. That is, in energetic terms, that would be the direction in which the energy propagates. Well, having seen and remembered these concepts, we are going to approach the Huygens principle. The Huygens principle is really a geometrical construction. And what it tells us is that every point of an initial wave front can be considered as a source of spherical secondary waves extending in all directions with the same velocity, frequency, and wavelength as the front from which they come. Put this way, the truth is that we are a bit at a loss as to what it is telling us. But surely if we explain it with an image, it will be clear to all of us. Well, let's consider these three initial wavefronts. According to the Huygens principle, all the points of the wavefront are going to become secondary spherical waves, right? Both this circular one and this one next to it and this last one. Well, the first two are homogeneous and isotropic. What does that mean? That all the points travel with the same velocity. Therefore, in the same time, they have traveled the same space. According to the Huygens principle, if we trace the envelope of these secondary waves, we would have the new wavefront. In the first case and in the second, being a homogeneous medium, we have said that the velocity is the same at all points, and therefore the wave fronts in the first case are concentric circles, and in the second one they are parallel planes. In this case, as we are drawing in 2 dimensions, they are parallel lines. What happens in the third case? In the third case, it tells us that the medium is non-homogeneous. Therefore, what it means is that the velocity of all points is not the same. An example of this would be the sea. In the sea, the velocity is different depending on the depth. If the medium is inhomogeneous, it means that the velocity of all the points is not the same, and therefore it travels through different distances even if the same time elapses. The envelope, again, because Huygens' principle has to be fulfilled, is the envelope to these secondary wave fronts. And therefore what we see is that in this case the wave front is not parallel to the initial wave front. I believe that with this it is much clearer what Huygens' principle tells us. Now just see what we have studied in this lesson. We have seen some previous concepts where we have approached the subject of the perturbation, the wave fronts and the ray, and finally we have introduced and understood Huygens' principle. That's all. See you in the next lesson.